Okay, so we're reviewing for a test, and the first thing I want you to attack is this. This one's got fractions in it. That's good because this whole unit is called rational functions, and rational numbers can be written as a fraction. So here's a fraction function. Who knew that we needed to times by 3 and x? Raise your hand if you knew that. Okay, good. That's a good first step. And then I'm going to let some things cancel. This 3 will cancel this 3. This x will cancel this x. Xing out an x kind of is confusing, so I'll scribble them out. And then I get 24x squared plus x equals 3. The first thing you have to know is you always set quadratics equal to 0. Did you already set it equal to 0? Raise your hand if you did. Okay, good. Then we're at 24x squared plus x minus 3. Now, if you had decided to move both of these over to the other side, you could have, but you'd have a negative lead term. Whenever you have a negative lead term, they're hard to factor. So I don't think that's a great idea. I would have done it this way. You get what I mean? If I'd have moved this over here, it'd be negative 24x squared over there, and that's harder to factor. All right, now I'll give you this much because some of you are going to sit there for too long trying to factor it. It's got an 8x in it. And right there, you can use logic now to go boom, 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 boom. It's got to be this. Okay? Figure it out and solve it. I'll pause for a second. I'll give that a try. By now, you should have known, well, duh, this has to be a 3x. That's the only way to make 24x squared. And then this has to be a plus and a minus. Now, where they are is up to, debate. But I can tell you this. There's no way that there could be a 3 here. And I want to show you why. It's kind of advanced factoring. Do you get a 3 would have factored out then? If a 3 could have factored out, we would have done it at the beginning. So the 3 can't be there. So then the 3 must be here. Now, whether it's plus 3 or minus 3, I don't know. But now it has to be that 3 and that 1. And now I'm going to check and see if I did it right. I go with the outside, negative 8x. I go with the inside, positive 9x. And I got lucky the first time. Otherwise, I would have switched the signs around. And my final answers then are, please write this, x equals negative 3/8 and x equals positive 1/3. Now, I'm about to change the question because that's one type of question we test you on. By just making this greater than right now, and greater or equal, and greater or equal, and greater or equal, then now, right now, I've done the first part, but if it's actually a greater or equal question, now you got to go do the number line thing and figure out whether those two spots work or not, and test intervals around them. So your final answer might be something like this. I'm not saying it is, but it could be something like that. All right? So take a moment and act like it was what's called an inequality question. I'll pause while you try that. So somebody noticed that if I had made this a greater than from the beginning, then we would have had to solve this a different way. We would have had to subtract something from both sides, not multiply by something. But either way, we could have gotten down to this moment where you had these two answers. But you're right, we wouldn't have been able to multiply by x on both sides. It's okay. We still could get to this moment where we have the two answers. And it's negative 3/8 and it's positive 1/3. And mostly I wanted you to go through the process of thinking, do these work or not? Well, they do work. They both work because neither one of them are asymptotes. They didn't make the bottom of an equation 0. They made the top of an equation 0. And another way to think that through is if I stuck in 1/3 into the problem, it will equal 0. And my symbol here says, will it be greater or equal to 0? So those two spots work. And now you're testing maybe 1, maybe 0, and maybe negative 1. Test those, see whether they work or not. I think you're going to find that more than one of them works. If you do it right, more than one place works. And what I mean by works is you stick that into the factored form. That's where I'd put it in. You put it here and you put it here. And it'll be greater than or equal to 0 in more than one of the intervals. Pausing again. Okay, so when you tested 1, you found out by putting a 1 in here and here that answer came out greater than 0. And so therefore it worked. And it also works here. And when you put in a 0, 0 here and a 0 here, then you got 3 times -1, which makes -3, and that's not bigger than 0. So it was negative in there. This is what they call a sign chart. It came out positive here, and negative there. And since we wanted things bigger than 0, then this area doesn't work. Okay, there's my final answer. And some people ask, are number lines allowed? Well, it depends. Problem says you have to be in interval notation, then you got to take one more step and write this. But I didn't say you had to answer in interval notation. Therefore, you could have just left me the number line. Any other questions? Yes?
I have a question. It's more about the first one. But why couldn't you factor out a 3 from 24 and 30?
Okay, so I was saying here that we couldn't have had a 3 right here, because then we would have had a 3x minus 3 as one of our factors, and if that was the case, 3 factors out. But the problem is right here, 3 can't factor out from all 3 parts.
Oh, because there's an x.
Yep,
Okay,
3 could factor from here and from here, but not from there. So that meant I knew that it could not be a 3 right there when I was choosing my factors. Okay, so next part, I'm going to give you a bigger on bottom, bigger on top, or same on both question, and you need to figure out what are the horizontal asymptotes for this thing. Ask Bob. Is this one a bigger on the bottom? Yes, and then what's the rule for Bob's? Y equals the outside. But what's on the outside? So then it's y equals 0. Do you get, if I had put a plus 3 here, then do you get it would have been y equals 3, because the whole thing would have moved up 3. Okay, but I didn't, so I won't. Now what are the vertical asymptotes? I warn you, this one's kind of a stumper for a lot of people. If you forgot where they come from, I'll show you in a minute. So a lot of people are like, so I'm going to try to figure out what makes the bottom 0, but I can't factor that thing. That's not the point. The point isn't can you factor it. The point is, can you even make it equal 0? No matter what you put in, can you ever find a way to make it equal 0? This would have to equal a negative number. The only way that could happen is if you threw an I in there, but that would make it imaginary, which makes it not real, and therefore there are no vertical asymptotes because there aren't any ways to make it 0. Unless you're talking imaginary things, and imaginary things don't create vertical asymptotes. All right, next one. Y equals x squared minus 3x minus 4 over x squared minus 16. Can you tell me, does that one have any vertical asymptotes? Well, it might take you a minute to see, because you better check and make sure if that thing you're thinking would give you a vertical asymptote actually is a hole. So tell me any vertical asymptotes, horizontal asymptotes, and holes. I'm going to give you HA, VA, and hole. And last but not least, on your hole, you got to give me an answer like 2 comma 3/4. It's got to be both parts of the hole, not just that x is 2. I'm not saying this is the answer. I'm saying the answer looks like that. Okay, I'll pause again. Find me the verticals, horizontals, and holes in this function. Okay, let's see how you did. The horizontals. Ask Bob. Well, this thing is bigger on the, well, wait a minute. It's actually same on both. So what's the rule for SOBs? Shh, listen, please. It's y equals a ratio. And the ratio here is of the lead coefficients, which is 1 over 1. So it's y equals 1. Raise your hand if you had y equals 1 there. Good sign. How about verticals? Verticals come from the bottom. What makes the bottom 0? It'd be very tempting to just say x equals 4 and x equals -4 if you're extra smart, because there's 2 answers. But one of them turns out to be a hole. because there was an x minus 4 on the top and the bottom. And if you did it right then, let me think here, minus or plus 1, there we go. Then this cancels, and that makes a hole at 4, so it can't be a vertical asymptote, it's a hole. And I know some of you got confused by the weird extra, what if there was another x minus 4? Well, if there was, then it would go back to being no, actually, then it would have been overruled and it'd be back to being an asymptote again. If there had been another x minus 4 down there, after I canceled this one, there was still an x minus 4. Then you'd have the deal where the asymptote is like an unlimited amount of holes and the asymptote would win. But this was a hole at 4. So that should have been the easy part. But how many of you think you got the right second part? 4 comma something. Kate, what do you guys think?
I got 4 comma 5/8.
5/8. Raise your hand if you had 5/8. That's almost everybody. And the way you get it is you put the 4 here and here. And your y equals that, 5/8. Okay, cool. Next thing I got to teach you is a reminder about finding word problems. So imagine I've got a garden in my backyard and I say I want it to be twice as long as it is wide. Twice as long as wide. Do you get that means the long side is bigger? The length is the long side, and the long side is twice as big as the other one. Okay, effectively I just gave you an equation. Here's the other equation I'm going to give you. Area, so you know what area is, right? In this case, it's 18 units squared. I'm going to say it's yards. 18 square yards. Now, that should give you 2 separate equations, which can then be put into one equation, and then can be solved. But the answer you'll get might be like 3. But then my question isn't, how long is one of the sides? My question is, what's the perimeter? Because we're trying to make a fence here. What's the perimeter of my fence? And one side might be 3, but you got to figure out the perimeter, which is all the sides. All right, so I want you to struggle with this for a bit. You're going to talk to the kid next to you about what you think the 2 equations are that I gave you. One for the red one for the black one. And then the final answer is the blue question. All right, good luck. Make sure you show some work. Pausing for a minute so you can work. Okay, thanks for your patience with trying to get a few things ready for your test tomorrow. And now here is the answers. If it's twice as long as it is wide, that means the length is the long side would be twice the width. Now, if I go into the other equation, area is length times width. Well, here's a fact about your area. It's 18. 18 equals length times width. And then this equation can go up into this equation, and the L is twice W. So then all of a sudden, I have 18 equals, instead of the L, I can put 2W times W. So 18 equals 2W squared. So 9 equals W squared. And right here, I know a lot of you just say, oh, the answer is 3. Technically, it's 3 and negative 3. When I square it both sides, you get the absolute value. I told you this would keep coming up. Absolute value of W is equal to 3. So then there's 2 answers, and you have to be smart enough to know there's 2 answers and that one of them doesn't actually work in reality. Now, I know some of you are going to be like, but I just put down the one that worked. Well, then you did it wrong. You're supposed to give both answers and then say, but this one's extraneous. So you have to be smart enough to know that there are 2 answers and that one of them actually doesn't work. Okay, you can't just forget. See what happens all the time is people forget there's 2 answers. Just write down 3. And yay, you've done it and gotten lucky because you didn't even notice that we were doing the square root of a variable. And now 3 is the length of one of the sides, but I'm not done yet. 3 is this side, and this side, the other side must be what? 6, because 6 times 3 makes 18. So you knew it had to be 6. And then the final answer is you have to add up all those sides. So you'd end up with This is 9, and this is 9, so it's 18 again. The perimeter final answer was 18. Okay, questions? Yes.
Didn't you say the area was 18? Why
Yep.
is it there?
Yep,
And why did you just plug in 18?
I did. I plugged in 18. You can't put in a unit in the middle of an equation. Yep, it's just units. At the end, I should give the answers units, though, so it's 18 yards. Yes? That's a good question. I don't know, but I know that if you put the units, I couldn't mark it off. So just try to remember to put the units. What I could see as I'd likely not mark it wrong if you forgot the units, but if I were going to mark it off for only the units, the most I'd take off is 5%, but most people don't want me to take off 5%, so put the units on it. Yes?
Why is there squared on the first unit?
Do you get how areas work? Areas are squared. So, like, back to geometry for a minute. So if this has got 3 feet on this side and there's 8 on the other side. 1, 2, 3, 4, 5, 6, 7. I guess I got to go a little further. I should have made one more. Here. That one's narrower too. And I know I didn't make them all squares, but imagine they were all squares. Then that's why they're square units. 3 on this side, 8 on this side. Do you see these squares? I know they're not all squares, but
then you highlighted too? Yards squared.
but it wasn't actually 8. But dang it, it was not 8. It was. Hold on. It was 3. Okay, by 6. 2, 3, 4, 5, 6. Okay, now imagine all those are squares. Now I got 6 on this side, 3 on this side. That's why the area was 18 square units. And now the volume, or not, the perimeter. Perimeters aren't squares. Perimeters is distances. Do you get distances aren't squares?
Yeah.
There you go. Okay. I think we covered everything that you have to know. Now, there are some practice problems in there with the key for the practice problems. I could have done those as my notes for today. Would have been way easier because it's already all worked out for me. I know all the answers. I'm not going to mess any up, but I left them for you because that way you got something to do tonight. You can do all the problems that are in the notes there as practice. Any of those that you don't understand, you can go look at the completed notes, which will show you the key for it. And now you got some things you could do to practice. Okay, so should you do any homework tonight? Of course you should. I've warned you that I think this is the hardest test we've had in a while. Not the hardest ever, but last test was pretty easy. This has got word problems on it, and we haven't even talked about the rate plus the rate equals the rate kind of questions. I suppose I should throw one of those in. So let's say I am able to pick 100 blueberries in 10 minutes. Yeah, I know, we did one like this. And my mom is able to pick an unknown number of blueberries in how much time, though? You got to tell me. It's either per minute, or it's per 10 minutes, or per 100 minutes. I'm going to say we don't know how many she picks per minute. But I know that when we worked together, she and I picked 700 blueberries in 8 minutes. Let's say 7 because it'll reduce so much nicer. 700 blueberries in 7 minutes. Do you get how I set that up? There was little Dave, the blueberry picker, and his mom, and this was together. And I can simplify these now. And remember how I set it up with the units, but then I can't actually use units in my equation. So I'm going to take this, cancel this, and it's 10 plus x equals, that simplifies pretty nice, 100. Bam, that was fast. What's x?
90.
My mom apparently picks 90 per minute. Pretty dang fast. Pretty unlikely, but that's how this one would work. Questions? Yes.
Get rid of the over one for the
What's x divided by 1? There you go. Yes.
Actually,
It's okay. All right. So that was a rate plus a rate equals a rate type question. You have some of those you can practice too. So you got about 10-ish minutes left, a little less. Feel free to come up and ask me one-on-one questions if you'd like. That's all I got for you for the video for today.